Hello friends, welcome back to our channel Abhi Chemistry Tutorial. So in this video we are going to learn a Reimer Tiemann's reaction, a very important and very simple reaction. So we are discussing organic naming reaction series and this is one of the organic naming reactions. So if you have not checked the other organic naming reactions in our channel, link of the playlist is given in the description box, and we also have a lot of other videos which may be useful for you. So before going to the video, I have a small request for you. So I will show a photo on the screen, and here you can see many people are watching without subscribing. So many of you are watching and getting benefited from my videos. So please take a second to subscribe to our channel and share the video to all your friends. Now let's get started. So Reimer Tiemann's reaction. So what is Reimer Tiemann's reactions? In symbol we can say when phenols are treated with chloroform in the presence of a base like potassium hydroxide or sodium hydroxide at 60 degrees Celsius, we get hydroxyaldehydes. So phenol, that is hydroxyaldehyde, that is salicylaldehyde. So phenol when treated with the chloroform and a base like potassium hydroxide or sodium hydroxide at 60 degrees Celsius, we get salicylaldehyde or hydroxyaldehyde. It is called Reimer Tiemann's reaction. So if we use heterocyclic compounds like pyrroles and indoles and subject to the same set of reactions, that is chloroform and base, at 60 degrees Celsius, we get formylated heterocyclic compounds. So what is formyl group? Aldehyde group or CHO group is called formyl group. So formylated heterocyclic compounds will be formed. So here the incoming group is CHO, that is aldehyde group, and it is directed to the ortho position. So you know this is a phenol and this is the ortho position. So the incoming group CHO will be directed to the ortho position. So if the ortho position is already occupied, then this is meta and this is para, so the incoming group attacks the para position. So if ortho position is occupied, the incoming groups attacks the para position. So for example, so this is phenol subjected to Reimer Tiemann's reaction, that is chloroform and KOH at 60 degrees Celsius, we get salicylaldehyde. So CHO is substituted at the ortho position, which is the major product, that is 40% of yield, and the para position substituent is only 10%, that is minor product. So the major product is ortho product. So mostly the incoming group is directed to the ortho position. But if you see in this case, this is glycol. If we subject this compound to Reimer Tiemann's reaction, the incoming group cannot attack the ortho position since it is already occupied. So this is the meta and this is the para position. So the incoming group attacks the para position. So CHO is present at the para position and this compound is vanillin. And here you can see catechol. Two hydroxy groups are at the 1,2 positions, that is catechol, and the same reaction takes place to give the substituent CHO at the para position since the ortho positions is occupied. So here you can see CHO group gets the priority. So the number starts from 1, 2, 3 and 4. So now the name becomes 3,4 dihydroxybenzaldehyde. So if carbon tetrachloride is used in the place of chloroform, acids will be formed instead of aldehydes. So for example, if phenol is treated with the carbon tetrachloride and sodium hydroxide instead of chloroform, then you get an intermediate at ortho position, that is CCl3, and this on hydrolysis we get salicylic acid. Instead of aldehyde, we get an acid, carboxylic acid, that is salicylic acid. So the next is the mechanism. So we can divide the mechanism into two parts. So the first part is the formation of carbene intermediate. So the formation of dichlorocarbene intermediate in this case. So we are first reacting so in this case the chloroform and the base first reacts to form the carbene intermediate. Let's see how. So the OH group, OH minus group from the base reacts with the chloroform. That is, the base abstracts the proton from chloroform so that you will get a carbanion. So here you can see OH minus abstracts this H plus and this bond shifts over this carbon to form carbanion, and this is the fast step. And this carbanion then in a slow step loses a Cl minus, that is, it will lose this chlorine along with the bond Cl minus, so that you have only two bonds filled, two electrons bonded to the chlorine atoms and two electrons are left to be bonded. Since carbon has valency 4, only 2 of its valence electrons are shared and 2 more electrons are there waiting to be shared. So this represents the carbene intermediate. So since we have 2 chlorine atoms here with this carbon, we say it is dichlorocarbene. For better understanding, I explain it once more. This bond is completely shifted over this carbon and this negative charge will have 2 electrons. And now you can see this chlorine shifts along with the carbon's electrons. So these 2 electrons are left over without bonding. So the carbon with the 2 electrons waiting to be bonded and 2 electrons are already bonded. This type of carbon is said to be a carbene. So this is a dichlorocarbene. So this is the second part. In the second part, the dichlorocarbene is attacked by a strong nucleophile, that is phenolate carbanion. So how it happens? So strong nucleophile means the nucleophile is nucleus loving group, that is, it should have a negative charge to attract the chlorocarbene. So let us see how. So this is phenol and this OH bond, the H plus is removed and this bond shifts over oxygen with a negative charge. So now this negative charge shifts over here to form a double bond with oxygen and carbon, and so this bond is shifted over this carbon to form a negative charge here. So this is the phenolate carbanion. So this phenolate carbanion will attack the strong nucleophile. So this negative charge makes a bond with this carbon. So this carbon makes a bond with this carbon to form CCCl2, and this 2 electrons will be remained as the negative charge. Since one more bond is formed for carbon, only one more bond is still to be formed. So this becomes a carbanion. Now here you can see this hydrogen is removed as H plus and this H plus bonds with this C minus to form CH. And this bond is shifted over here, and so this double bond is broken and one bond goes over this oxygen to form O minus. So this is the phenolate carbanion and this is dichlorocarbanion. And from this we get a phenoxide ion with the dichloromethyl group. So CHCl2. So a phenoxide ion with the dichloromethyl group, and this on hydrolysis 2 HCl's are removed. 2 HCl's are removed and these 2 bonds become a double bond with oxygen, that is CH double bond O. So we get an aldehyde group at the ortho position. So this is salicylaldehyde. So this is the final product we get from phenol on Reimer Tiemann's reaction. So here we have some more examples. So in the case of heterocyclic compounds, for example, if we use thiophene, that is a heterocyclic compound with sulfur, when it is subjected to Reimer Tiemann's reaction, we get an aldehyde group substituted at the second position. So this is the first position, this is the second position. So it is thiophene 2 aldehyde. If we use pyrrole and subject to Reimer Tiemann's reaction, we get pyrrole 2 aldehyde. And the next reaction is the formylation of naphthol. So what is formylation? Aldehyde formation, that is addition of formyl group, CHO group to naphthol. So naphthol, this is the structure of naphthol. So from this we give number 1, 2. So 2 OH, so 2-naphthol. Second position we have OH, so it is called 2-naphthol. On Reimer Tiemann's reaction, we get the CHO substituted at this first position, CHO. So now the priority goes to CHO. Now it becomes 1, 2. So 2-hydroxy, 1-naphthaldehyde. And the last example is preparation of piperonal. So this is catechol. And when we subject this to Reimer Tiemann's reaction, if this is the first position, then the ortho position is filled by OH. So this is meta and this is para. So the incoming group CHO is attached to the para position. So the CHO group gets the priority. So now the naming goes like this: 1, 2, 3, 4. So 3, 4 dihydroxy benzaldehyde. So now we are treating this 3,4 dihydroxy benzaldehyde with CH2I2 diiodomethane with sodium hydroxide base. We get piperonal. So for the preparation of piperonal, Reimer Tiemann's reaction form the bases. So this is all about Reimer Tiemann's reactions, and I hope the video is useful for you and you might have learned clearly the Reimer Tiemann's reaction. So please give a like to our video and share to your friends, and don't forget to subscribe to our channel. So many other videos are also waiting for you in this channel. So please subscribe and click the bell button to get the notifications whenever I upload the new videos. So see you all in the next video. Until then, bye. Thank you. Take care.